Hello, welcome to the channel. On this video, we are going to discuss one problem which is taken from the IMO Shortlist 2018, which is problem A1. So on this problem, we are looking for all functions from positive rational to itself such that it satisfies the following equation. F of x squared times f of y squared is equal to f of x squared times f of y. Okay, so as usual, when we have a functional equation, so the first attempt should we plug and chug. Maybe something interesting appear after we plug in several values. So one of the obvious attempt that we should try, because we have lots of multiplication, is to plug in x equals 1, for example, right? Let's see what happens if x is equal to 1. Then we have f of fy squared is equal to f of 1 squared fy. Well, it seems not very helpful at the beginning. Okay, next let's try to plug in x such that this multiplication is equal to 1. So basically, I would like to have this multiplication is equal to 1. Therefore, I can choose x to be equal to 1 over fy. Okay. Then the statement reads f of 1 is equal to f of 1 over f of y squared times f of y, right? Now if we plug in y equals 1, then we have f of 1 over f of 1 squared is equal to f of 1 divided by f of 1, which is equal to 1. Okay, so this is basically, we know that we have a rational number such that when we square it, we get 1. But since this f of stuff is a positive rational, then we conclude that f of 1 over f of 1 must be equal to 1. Because in the beginning, we have two options. This number can be equal to 1 or can be equal to -1. But since we work on the positive rationals, then this must be 1. Okay? So from this equation, at least we know that there exists some positive rational which is being sent to f to 1, right? So if we plug in y equals 1 over f1 here, right? So let's say this 1 over f of 1 is equal to z, right? So if we plug in z there, what do we get? So f of z is equal to 1, right? So this is going to be 1. F of 1 is equal to f of 1 squared, this is f of z, is equal to 1, right? Then we conclude f of 1 is equal to 1 or 0, but we are working on the positive rationals. Therefore, f of 1 is equal to 1. Okay. Now, since f of 1 is equal to 1, if we plug in y equals 1 here and there, what do we get? F of x squared is equal to f of x squared, right? And now if we plug in x equal to 1, or let me use this one. So f of 1 is 1, right? So we have f of y squared is equal to f of y. Okay, so from this previous equation, this guy can also be rewritten as what? So this is f of something squared, right? It can be written as f of fy squared. Okay, so let us put this important equation in a box. We have f of y squared. I'll be write down something like this is equal to f of y, right? So that's what we have for now. All right, so now what do we get if we replace the y itself with f of y? We have fy squared is equal to f of fy. But before, if we square this expression, we get f of y. Okay, so let's square both sides of this equation. So what do we get? F cubed y to the fourth is equal to f squared y squared, which is again equals f of y. Okay, now you can do the same trick here, and you can prove by induction that f of n to the y to the power of 2 to the n minus 1 is equal to f of y. Right? So we have, when n equals 3, we exactly have this one. When n equals 2, we have exactly this first statement, right? Yeah, you can try to prove it inductively. Okay, so, but what this equation tells us? It tells us that we have a rational number such that this rational number is can be written as a power of some other rational number. So maybe let me put some lemma. So lemma, let R be a positive rational such that there are infinitely many Qn in Q plus such that Qn to the power n is equal to R. Then R is equal to 1. So basically from this lemma, if this lemma is true, I think you can try to prove it yourself, this lemma, right? So if this lemma is true, then we conclude f of y must be equal to 1, right? So the hint for this lemma, look at the VP, the valuation of q and n and well, I can basically, this is the proof, right? So the valuation of p on this rational number is exactly n vp q to the power of n. So in particular, n divides vpr. Since there are infinitely many, so this number is divisible by infinitely many n. And the only integer satisfying that property is 0. 0 is the only number that divisible by infinitely many other integers. So therefore, this guy is 0, and we conclude r must be equal to 1. So therefore, in conclusion, that the only function satisfying this equation is the function that sends every positive rational to 1. Okay, so therefore f of x equal to 1 is the only solution to the functional equation. All right.